All right, welcome back. This is the systems unit review for Algebra 1 Honors. So let's take a look at number 1. Tell whether the point 4 negative 7 halves is a solution to the linear system. So it's going to be a solution if that ordered pair, which we know that ordered pair is always x, y, if that ordered pair works for both the first and second equation. So we're going to go ahead and plug it in. So for equation 1, we've got 3 times 4 plus 2 times negative 7 halves is equal to negative 1. So I get 12 minus 14 equals negative 1, and negative 2 equals negative 1 is what we're looking at here. And obviously that's not true. So we are done. We don't even need to bother checking the bottom one. So no, it is not a solution. Number 2, at a farmer's market, a customer pays $16 for 4 apples and 4 oranges. Another customer pays $17 for 3 apples and 5 oranges. Wants us to write a system for the cost of 1 apple and 1 orange. So we're paying $16 total for customer 1, so that's 16 equals, and that's 4 apples and 4 oranges, so it's 4x for apples plus 4y for oranges, because it's the cost. It's the cost of an apple times the number of apples plus the cost of an orange times the number of oranges equals the total cost. We're going to do the same thing for the second customer, which is going to be 17 equals 3x plus 5y. So there's my system. And part B, solve the system of equations and describe your steps. So when I look at this, 16 equals 4x plus 4y and 17 equals 3x plus 5y, we've got 3 methods. We can graph it. I'm not going to graph this. We're going to use algebra. But we could graph it. We can use substitution or we can use elimination. For this particular problem, substitution is not going to work well because I have to get either x or y by itself. I'm going to use elimination instead, and I'm going to try to get the x's to cancel. So to do that, I'm going to multiply the top equation by 3. That's going to turn this x term into 12x, and I'm going to multiply the bottom equation by negative 4, and that's going to give a negative 12x on the bottom. So that step is multiply top by 3 and bottom by negative 4 to cancel x's. So when I do that, I get 2 brand new equations of 48 equals 12x plus 12y, and negative, that's going to be, let's see, 40, that's going to be 68 equals negative 12x minus 20y. And now that I have opposites here for my x's, I can add my 2 equations. I get negative 20 is equal to 12 minus 20 is negative 8y. Divide by negative 8. And I get y equals 20 over 8, which is 10 over 4, which is 5 over 2. And since this is money, 2 divided by 5 is 2.5. So y equals $2.50. So that's the cost of an orange. So here I'm going to say we used elimination and solve for y. And then I'm kind of running out of space here, so I'm going to not write down all my steps, but what we're going to do now is we found the cost of an orange, Now we have to find the cost of an apple. So we have to go back up to one of the top two equations, and I'm going to go with the top one, 16 equals 4x plus 4 times 250. So I'm just substituting this y value back into my first equation. So 16 equals 4x plus 10. Subtract the 10. 6 is equal to 4x divided by 4. And that leaves me with x is equal to, 4 goes into 6 one time, and I've got 2 left over, so that's $1.50. So that's the cost of an apple. So we can say an apple is $1.50, and an orange is $2.50. All right, moving on to number 3. Again, we're solving the system. Once again, I can use graphing, I can use elimination, or I can use substitution. Once again, when I look at this, I notice that I probably don't want to graph it. Substitution might be okay. And in fact, let's go ahead. I'm going to use substitution on this one just so we have different methods on this video. So to substitute, we need to get a variable by itself. What we could do is divide the entire top equation by 3 to get y by itself, or divide the entire bottom equation by -8 to get that y by itself. But in both of those cases, I'm not going to get very nice numbers. So what I'm going to do instead is I'm going to solve the bottom equation for x. So to get x by itself, I'm going to add the 2. So I get -8y plus 2 is equal to -2x. And then I'm going to divide everything by -2. So I'm going to be left with 4y minus 1 is equal to x. That is the equation that I'm going to then substitute into the top x value. So to do that, I've got 3y equals -4 times 4y minus 1 plus 15. Distribute 3y equals -16y plus 4 plus 15. And we know we substituted correctly because I'm down to just a single variable. I've got y's on both sides. I'm going to add the 16y. So I get 19y is equal to 19 when I combine my like terms. Divide everything by 19. Y is equal to 1. So that's my y value. Now I'm going to substitute this y value back up over here to get my x value. So that's going to be 4 times 1 minus 1 is equal to x. So 4 minus 1 is equal to x. So 3 equals x, and that leaves me with an ordered pair of 3, 1. Number 4, solve the following system by graphing. So to graph, there's a couple things we can do. We can either find the intercepts or we can get y by itself. So again, for the purposes of the video, I'm going to do one of each. The top one, I'm going to find the intercepts. We know that the x-intercept, y has to be 0, and for the y-intercept, x has to be 0. So for my x-intercept, I'm going to have 2x equals -3 times 0 plus 15. So 2x is equal to 15. So x is equal to 15 over 2. That's my x-intercept. And for my y-intercept, I've got 2 times 0 equals -3y plus 15. Subtract the 15. -15 equals -3y. Divided by -3. Y equals 5. So I can plot those points. 15 halves, that's going to be 7.5. Puts me there. And my y value is 5, which puts me here. And now I can draw that line. Remember, we want to make sure we're using a ruler to get a nice straight line, because we need to be pretty accurate about where it intersects. Alright, and then the bottom equation, I'm going to solve for y. So I'm going to subtract 2x. So negative y is equal to negative 2x plus 3 divided by negative 1. So I'm left with y equals 2x minus 3. That means I have a y-intercept of negative 3, and I have a slope of 2. And it looks like they're going to intersect right there. Let's go ahead and finish drawing that line. And now that I've got the line drawn, my solution is where those two lines overlap, which is at the point. See, that's going to be 3, 3. And if we're not sure, we can always take that ordered pair, plug it back into both equations, and verify that it works. All right, number 5, use a graph to solve the system. So once again, we're going to graph. I can get y by itself, or I can find the intercepts. And when I look at the top one, it's pretty obvious what's going to happen. If I make x 0, then I get negative y equals negative 3, so y has to be 3. So it has a y-intercept of 0, 3. And if I do the same thing, but this time make y 0, I get an x-intercept of negative 3, 0. So I've got negative 3, 0, 0, 3. Go ahead and draw the line. There we go. And the second line, once again, I can plug in zeros. So if I'm looking at my x-intercept, making y 0 this time, so I get 2x equals 0, so x has to be 0 and y has to be 0. And my y-intercept, plugging in 0 for x this time, so I get y equals 0. So I have a line that looks like that. That doesn't really help me though, unfortunately. So I'm going to need to find the slope of that line. So I'm going to subtract the 2x. So y equals negative 2x, which means I'm going down to right 1. And again, it looks like I've got my point of intersection. Go ahead and draw the line. Ooh, that wasn't even close. There we go. And so our solution is at the point negative 1, 2. 6, given the system, determine the solution. So what's probably going to be easiest, because if we look, we've got 4 multiple choice answers, and then down below it says prove the answer you selected is the solution. So might as well just solve it, because we're going to have to do the check anyway. So 2x plus y is equal to 0. So the easiest thing to do here, if I'm looking, it's already set up for elimination because I already have opposites. So if I just add, I get 3x equals negative 3. Divide everything by 3. X is equal to negative 1. And right there, I know that my answer is B, but I'm just going to double check that by finding the y value. So I take that negative 1, plug it back in. I'm going to plug it into the top. Negative 1 minus y is equal to negative 3. Add the 1. Negative y is equal to negative 2. Divide by negative 1. Y equals 2. So I've got an ordered pair of negative 1, comma 2, which matches the answer that I thought it was. Number 7, write the system of linear equations graphed below. So we need to find the equation of these two lines. Well, remember that the equation of any line is y equals mx plus b. M is the slope, b is the y-intercept, and lucky for us, we can see the y-intercepts for both lines, and we can certainly find the slope. So keep everything color coordinated. Looking at the green line has a y-intercept of 1 and has a slope. So if I count from this point, I go up and over to this point, that's up 2 over 1. That's the slope of 2. So that line is y equals 2x plus 1. And my blue line has a y-intercept at negative 2. And that one has a slope from any point to any other point that we know. We go up 1 over 2. So that's going to be 1/2 x minus 2. Number 8, write the system of the linear equation graphed below. So once again, let's see, I'm going to go ahead and label these as line 1 and line 2. And I can see my y-intercepts. And I can certainly find the slopes. So for line 1, we have a y-intercept at 7. And it looks like the slope is going to be down 1 over 2. So it's negative 1/2 x. And equation 2 has a y-intercept at negative 2. And this one has a slope of up 1, 2, 3, 1, 2, 3, 4 over 1. So that's a slope of 4x minus 2. Number 9. A revenue of $2,310 is obtained from the sales of item A at $80 each and item B at $30 each. There are 57 items sold together. Write a system to model the situation. So we're going to make, I see two things here. I see a cost and I see a number of items. So I'm going to make two equations. The first one is cost. The second one is items. So the cost, it's $80 for item A plus $30 for item B. And so 80A and 30B, those are going to be the cost, like the total cost of those items. I'm going to add them together to get a overall total cost of $2,310. And if we sold 57 items, that means that was a combination of A plus B equals 57 items. Part B, we need to solve this system to determine how many of each items were sold. So once again, I've got my system of equations. 80A plus 30B equals 2,310, and A plus B is equal to 57. I'm going to use elimination here. So I'm going to multiply the bottom equation by negative 30. So my two new equations, the top one stays the same, 80A plus 30B equals 2,310, and the new bottom equation is negative 30A minus 30B equals, see, 57 times 30 is negative 1,710. So now we have opposites, so those cancel out. I'm left with 50A equals 2,310 minus 1,710. That's going to be 600. So divide both sides by 50. A equals 60 over 5, which is 12. So that means we sold 12 of item A. And we know that A plus B is 57. So if we sold 12 of A, and we have to sell 57 altogether, and we can subtract 12, and B equals 45. So the company sold 12 of item A and 45 of item B. Number 10, write the system of linear equations represented by the two tables. So once again, to write the equation of a line, we need a slope and a y-intercept. So we're going to have to come up with another equation, y equals mx plus b. And we're probably going to have to use point slope form as well. Y minus y1 is equal to m times x minus x1. So I'm going to use these first 2 points. So my slope here, m equals, 0 take away 8 over 3 minus negative 1. So that's negative 8 over 4, which is negative 2. So y equals negative 2x plus something. And I'm going to use my point slope form now. I'm going to pick this point because it's real easy to use because we've got a 0 in there. So we've got y minus 0 is equal to negative 2 times x minus 3. So if I distribute, that cancels out. I get negative 2x plus 6. That's my first equation. And my second equation, again, I'm going to use these first two ordered pairs that I see. And once again, m equals, let's see, it's going to be 5 minus 5 over 0 minus negative 1. So I get 5 minus 5 is 0 over 1, which is 0. If my slope is 0, that means I have a horizontal line, which means it's an equation y equals something, and that something is whatever my y-intercept is. And remember, a y-intercept is always in the form of 0, comma, whatever b value we have. So we can actually see it right there, that it's 5. Not to mention, when we look at the table, all my y values are 5, so that's a pretty big clue. So this equation is just y equals 5. Moving on to number 11. Write a system of linear inequalities that defines the shaded region. So we've got two lines. They're inequalities. We can see that on this red one we're shaded what looks like below the line, and on the blue one, which is dotted, we're shaded above the line. So we're going to start by writing the equation of the line just like we did in a previous problem. So for the red one, I have a slope and a y-intercept. My y-intercept appears to be at 2, and my slope, if I start down here, I go up 1, 2 over 1. So that's a slope of 2 over 1, which is 2. So we have an inequality of y is less than, because we're shaded below it, and it's less than or equal because it's solid, 2x plus 2. Now we look at the blue one, and that one has a b value of negative 2, and this one has a slope. If I'm looking from this point to this point, I'm up 1, 2 over 2. It's 2 over 2, which is 1. So this is an inequality of y is greater than, because I'm shaded above, and it's just greater than because it's a dashed line. Y is greater than 1x minus 2. And you can, if you're doing these by hand, or if you're doing them on the test, you can always use the calculator to verify your answer. You could also plug some points in, make sure it works. We're just going to move on for this one. 12, graph the linear system of inequalities. So we're just basically doing the opposite of what we did up above. Remember, to graph, we're going to want to get y by itself. So if I subtract the 3x from both sides, y is less than negative 3x plus 2, so that has a slope of negative 3, a y-intercept of 2, and the second one, I'm going to add 8x, so I get 2y is greater than or equal to 8x minus 2, divide everything by 2, so y is greater than or equal to 4x minus 1, which means I have a slope of 4 and a y-intercept of minus 1. Remember, when you're solving inequalities in order to graph them, if you divide by negative, you have to flip the inequality around. So let's go ahead and graph this. We're going to graph the red one first. Y is greater than or equal to 4x minus 1. So we're going to start at negative 1. And we're going to have a slope of 4, so I'm going to go up 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. And we can go the other way, 1, 2, 3, 4 backwards. So there's my line. We want it to be a solid line. So we have that. And when we look at the shading, we're going to check a point. We're going to check 0, 0 because we don't go through it. So remember, we always like to check in the original equation. So it's negative 8 times 0 plus 2 times 0 is greater than or equal to negative 2. Gone, gone. 0 is greater than or equal to negative 2. That is true. So that means we're going to shade the 0, 0 side of the line. So that's going to be on the left in this case. Now we graph the blue one, and that had a starting point of 2 and a slope of negative 3. So down 1, 2, 3 over 1. And we can keep going. And we can go the other way. And this one should be a dashed line. And see, this program that I'm using is not going to let me make a dashed line automatically, so I'm just going to have to hand draw it in there. So there's my line, and I'm going to check a point in here. So again, I can check 0, 0. So if we check 0, 0, we get 3 times 0 plus 0 is less than 2. 0 is less than 2. That is also true. So we're going to shade the 0, 0 side, which is all of this stuff. So just like we talked about in class, we've got 4 regions. We've got this section over here on the right that is not true for anything. This section at the top, this little triangle at the top, that is only true for the red function, the bottom function. This section at the bottom, which is only true for the blue function, which is the top one. And then we have this section over here on the left that's true for both functions, and that's where my solution is. So I'm going to pull out my highlighter, and I'm going to highlight all of that, because that's where my final solution is going to be. Is any point that I pick in this region will be true for both equations. All right, and then looking at the very last part of that question, which of the following are solutions to the system? So we have to check all of these. Is 2, 2 in the highlighted region? Well, 2, 2 is over here, so nope. 0, 0. Yep, it's right there. It's right in the middle of the green stuff. And we knew that was true because it was true for both of the checks, so that is for sure true. Negative 1, positive 5. So negative 1, positive 5 is, that's a tricky one because that one is right here on my blue line, but my blue line is dotted, Remember, if it's dotted, it's not true for that function, so that's not going to work. And -4, -5, that's going to put me here, and that is inside the green, so that's going to work. So I've got 2 that work, 2 that don't work. That is the end of the linear systems review. Thank you.